Hello again. Here we are with the AMOS project, a lecture on agile programming. We just talked about developer communication and coordination, and now we will talk about programming practices. The individual software developers work as they go about their daily business. I need to explain a couple of shorthands, acronyms that really stand in for basic principles of agile software development. You need to understand them because at least old-timers will still be using them all the time. It's a kind of shorthand to communicate a particular purpose. Sometimes also, if you will, an in-group thing that's really not necessary any longer now that agile isn't really battling waterfall any longer. So the first one to know is KISS. That's actually a general one. Keep it simple, stupid, or silly. Meaning don't go for complex solutions if you have no particularly important reason to go for a complex solution. And so choose the simplest solution that you can think of, typically because you ain't gonna need it. Yagni. If you decide that there's a complex solution and you want to choose that because you're expecting all these future problems will be avoided because you choose that complex solution now and it covers all the bases. According to agile methods or extreme programming here, don't do it because you ain't gonna need it and you should keep it simple. And the reason is that your speculation about the future and the future requirements and that all these complexities are coming down will be coming down at some point of future. That's a prediction of the future and more often than not. So the assumption of agile methods, you will be wrong. That of course is not a well-liked assumption by senior or experienced software developers who based on their experience actually feel certain that certain complexities will happen to you and that it would be the most cost-efficient way of addressing them now rather than later when they materialize. But agile methods still tell you don't do it, address the issue only when they are at hand. Now, as you're programming, as you're a software developer coding, you should follow the DRY principle, don't repeat yourself. That simply means writing simple, lean code. And as you discover duplication, you start repeating yourself, factor things into their own methods, etc. We will actually talk about that a couple of slides down the road in this talk as well as part of refactorings. Then here's an old adage which I particularly like, which also comes down, I think, through Kent Beck into extreme programming practices. Make it run, make it right, make it fast. That's the order in which you should address a new feature. First, you make that new feature functionality work. You make it run. You don't quite care about doing it perfectly right. You just care about getting it to run. Now that you know what it is, what it does, how it works, you can make it right. So only in a second step, make it well done code. You change your code so that it's now lean and smart code that does the functionality that you developed in the first place and make it run. So after you've made it run and after you've made it right, only then make it fast, meaning only then start optimizing for any performance or other reasons. The evil of software development is, as they say, premature optimization, because it will get in the way of getting it right, making it right. So first make it run, then make it right, and finally optimize and make it fast. All of this is part of avoiding this, creating a slum, I guess, or spaghetti code, or as it's sometimes been called, a big ball of mud. That's a well-known metaphor by now. That sloppy jungle of code that is extremely easy to get lost in And once you're lost you don't quite know what you're doing, and any changes you're doing to your code will only increase the complexity and the jungle until you're completely tangled and tied down by poor spaghetti code. You don't want that. You want nice and easy code that's easy to change for the purposes of your estimation of how complex some code change, some implementation of a feature will be right on target, and will be similar to previously determined sizes for similar size features. Again, for the purpose of maintaining a constant development speed. And that again is achieved by, as I just said, having a reasonably high quality code base that allows that precise or reasonably precise prediction. So you want so-called well-factored code, clean code. And it has these benefits. It's maintainable, you understand what it does, it's extensible or changeable, you can fix it up, you can add new functionality, and as just pointed out, it's the primary property of your source code base that allows you to predict the size and complexity of future work, and without it you wouldn't be able to plan, and all your product release, burn downs, etc. release plans would be for nothing if you don't achieve that quality and predictability. All right, so we'll have a nice video by one of the greats of the Agile movement and many other things. It's Ward Cunningham talking about technical debt, and where do I have it? And it must be here somewhere. Where is technical debt? Shared content. And so I will be uploading it right now. And here we go. Here we are again after a successful upload, and now let's listen to Ward Cunningham talk about technical debt.
I became interested in the way metaphors influence how we think. After reading George Lakoff and Mark Johnson's Metaphors We Live By. An important idea is that we reason by analogy with the metaphors that have entered our language. I coined the debt metaphor to explain the refactoring that we were doing on the Ycash product. This was an early product done in Digitalk Smalltalk. And it was important to me that we accumulate the learnings we did about the application over time by modifying the program to look as if we had known what we were doing all along, and to look as if it had been easy to do in Smalltalk. The explanation I gave to my boss, this was financial software, was a financial analogy I called the debt metaphor. And that said that if we fail to make our program align with what we then understood to be the proper way to think about our financial objects, then we were going to continually stumble over that disagreement, and that would slow us down, which is like paying interest on a loan. With borrowed money, you can do something sooner than you might otherwise. But until you pay back that money, you'll be paying interest. I thought borrowing money was a good idea. I thought that rushing software out the door to get some experience with it was a good idea. But that of course you would eventually go back and as you learn things about that software, you would repay that loan by refactoring the program to reflect your experience as you acquired it. I think that there were plenty of cases where people would rush software out the door and learn things, but never put that learning back into the program. And that by analogy was borrowing money, thinking that you never had to pay it back. Of course, if you do that, with your credit card, eventually all your income goes to interest, and purchasing power goes to zero. By the same token, if you develop a program for a long period of time by only adding features and never reorganizing it to reflect your understanding of those features, then eventually that program simply does not contain any understanding. All efforts to work on it take longer and longer. In other words, the interest is total. You'll make zero progress. A lot of bloggers at least have explained the debt metaphor and confused it, I think, with the idea that you could write code poorly with the intention of doing a good job later, and thinking that was the primary source of debt. I'm never in favor of writing code poorly, but I am in favor of writing code to reflect your current understanding of a problem, even if that understanding is partial. If you want to be able to go into debt that way by developing software that you don't completely understand, you're wise to make that software reflect your understanding as best you can. So that when it does come time to refactor, it's clear what you were thinking when you wrote it, and making it easier to refactor it into what your current thinking is now. In other words, the whole debt metaphor, or let's say the ability to pay back debt and make the debt metaphor work for your advantage depends upon you writing code that is clean enough to be able to refactor as you come to understand your problem. I think that's a good methodology. It's at the heart of extreme programming. The debt metaphor is an explanation. One of many explanations of why extreme programming works.
All right, here we are again. So you just listened to Ward Cunningham explain technical debt, a metaphor to help us understand what's going on with our code by borrowing from everyday life experiences of having a loan and paying interest on a loan. The benefits, as you can see, of that metaphor are really that it communicates well. In particular, it communicates well to non-technical people, as your managers sometimes might be non-technical and may not have an understanding of why, for example, what Ward called refactoring, cleaning up your code, why that would be necessary. So what if the code is messy, the customer never sees it? Well, the debt metaphor tells you what that would do to your code if left unattended, uncleaned. You will start paying interest more and more, and if you never pay back the principal by cleaning up your code, then ultimately you will lose all the benefits of being able to predict where you're going. I liked it particularly that he pointed out, well, sometimes it's actually okay to take on a loan because you can speed up things, you can learn, but you should never forget to, staying with the metaphor, to pay back the principal amount you loaned, so that in the end, after a while, you're always back to a reasonably clean code base. What that specifically is may depend on the project and all, but of course, make sure that it's good enough for reasonable predictions about speed, because otherwise you're not going to get the benefits of all the planning and product management planning and tracking. So then he mentioned refactoring, how to clean up, how to repay your technical debt. not just the interest. The interest is you're being slowed down. Paying back the principal means cleaning up code so that in the future you will not be slowed down because you have no interest to pay. And this is the domain of refactorings. First, you need to identify the problem. This is called smelling bad codes. So you track down code smells. Then you identify whether the smell is actually so bad that you need to act. And then as you decide you have to act, you apply a so-called refactoring, you refactor your code. And this term of refactoring is really from the 90s. Of course, people have cleaned up their code before that, but refactoring gave it a nice new term. And the trigger for refactoring are the code smells, some violations of good coding practices. For example, a violation of the dry principle, of the do not repeat yourself principle, because there's lots and lots of repeated code out there. What's so bad with repeated code? Well, it's more code than you would need. It's good to have less code. It's bad to have too much code. Also, as you might discover in a code that is based on a clone, copy and paste orgy, if there was a bug in the original code, you have that same bug now spread over 20 places in the code. So one place for one piece of code and one place only. So code smells, not smell the roses, smell the bad code and figure out what to do about it. Code smells are not bugs. The code might be doing its job, but it's an indication of interest you have to pay, meaning you're being slowed down in future development. Here are a couple of example code smells that have been defined as part of the refactoring movement. Duplicated code, violating the dry principle, or an overly long method, doing too many things, or a large class that indicates you are not quite sure what the class is about. In a well-factored design, it should be multiple classes. You've just glued it all together in one, and that's probably not good. That's a smell. Is it bad enough to go about to deal with it, to do any changes? You don't quite know. We'll look at this in a second. So then a smell might lead to a refactoring, and a refactoring is, by definition, a behavior preserving transformation of existing source code. Behavior preserving transformation means you're not going to add any new functionality. You're not going to create more business value for the customer. All you're going to do is make the code leaner, simpler, easier to understand, so that in the future any changes you apply to the system will be easier than if you didn't apply that refactoring. So you don't change the behavior of the code, you just change its structure. This term was defined in a dissertation by Bill Opdyke and picked up and popularized in a widely read book called Refactoring by Martin Fowler. These refactorings have been codified as, for example, one is rename a class. Well, if the class has a really bad name that doesn't indicate what the class is about, then you should rename it. That's a very simple refactoring. Or pull up a field. You notice that in a couple of subclasses of one class, there's being a field redundantly defined. So maybe you should pull up that field into the superclass, make it accessible through an inheritance interface to the subclasses, and thereby reduce code, make it shorter, make it simpler, create less code. Same thing with extract a method. You see the same code being done over and over again, so you change your code base to extract this method from multiple places into one. Refactoring.com will give you more examples, or you just look at the book. Our library has plenty of copies of it. Here's an example, very simple one, which would be extract method. Within the class photo manager from Valside, from the Flowers application, you can see uses of access to some hash map here, all photos, and in 3 different places you access that hash map by putting a photo there under the photo ID, and it would be a good idea to extract a primitive access method, set method here called do_put_photo or do_add_photo. And as you can see, I've applied the refactoring here. The 3 uses of this method are put in bold. It's simpler now, and the do_add_photo method is a so-called primitive method. It's protected, the outside world doesn't see it. It is the only place now, one single place where you know about the implementation decision of using a hash map for storing all the photos. And so this is a simple extract method, refactoring. So again, you smell the bad code. Should you always, when should you actually refactor? Well, not necessarily right away when things start to smell. They're defined points of time. You just added functionality. So you just made your feature run. Step 1 in the process of making it run, making it right, making it fast. You added functionality and there's dirt flying around the place. So you need to clean up. So after function, you do refactor to bring the code back into a good state. You fixed the bug. That also may mean that after that you need to clean up. Or you were reviewing code and you realize that this introduced more complexity than needed, that it could be much simpler. So after you accepted the new code and reviewed it, you do apply a refactoring to clean it up. There's the 3 strikes rule, a heuristic to help you decide on do you need to refactor. And as much of agile methods and extreme programming practices, it's pretty pragmatic. You look at something, you do the job, all right, you're done. You do a similar job and you realize you're introducing some redundant code. So there's the same code now a second time. Do you jump right into a refactoring? No, having the same code twice or similar code twice is not quite a bad smell yet. That happens all the time. Of course, code looks similar. You run into it for a 3rd time. Okay, now it's time to refactor. You find some redundant code 3 times. Now you should perhaps extract it into a method or pull up that field with appropriate methods, etc. The 3 strikes rule means wait for the 3rd time for it to happen and then you refactor. Here's the little process model called also the 2 hats you might be wearing. You first work on the functionality, you add the new function, you add the new feature, and then after you've finished that, after you've made it run, then you smell, and if it smells, then you go into refactoring mode. You take off your add function hat and you switch to the refactoring hat. And you keep refactoring until the code is clean again, meaning it doesn't smell. And then you go back to add function and you will deliver the next feature, the next functionality. As you can see, all of these smells might have multiple solutions. So for example, duplicate code could lead to an extract method refactoring, a pull-up field refactoring, or a decompose conditional refactoring, etc., etc. It really depends. And sometimes it leads to multiple of those refactorings. Now, refactoring processes can become quite complex. So first of all, before you engage in a refactoring, make sure the functionality was finished and is working well. Don't start a refactoring in the middle of adding a function. It requires discipline to do that, but you should develop that discipline. Now then that you've made it run, now then that it's working all right, now it's time to clean up if it's just smelling too badly. So you switch to refactoring. If it's a lot of refactorings, think it through. Make it make it a sequence of steps, all of which are individually motivated, improve the code, all of which are semantically close. So after each step, you have a good code base again, smelly perhaps, but the last refactoring didn't introduce more problems than it solved. So as you are looking at a lot of code smells, maybe you're taking over an old code base that needs cleaning up, break things down into smaller incremental refactorings, all of which are semantically close, all of which are smaller changes, refactorings that lead you from one stable state of the code base to the next. And so, for example, a complex switch statement might be fixing that up, might be turned into a sequence of an extract method, move method, replace type code with, say, a subclass, polymorphism, and finally replace that conditional with polymorphism. Refactoring, just a sequence. Plan it through to not get lost in the woods. The good thing about refactorings is it's supported, they are automatable to quite some extent. It's a process where you provide some input parameters and then a tool like a modern IDE can do the rest of the job. So say the Eclipse IDE gives you context-dependent refactorings. You just right-click and the IDE will tell you what refactorings it could possibly apply. And if you select one, well, you are just asked to provide some input parameters and then the rest of the refactoring will be done automatically. Nice and easy because these refactorings have been formalized, and of course the machine performed refactoring will introduce much less bugs, more likely less bugs than if you did it by hand. Any guesses as to what's the most common refactoring being applied in IDEs in general and then through the user interface of the IDE as an automated process? Well, research shows it's, yes, you in the back, yes, tell me, what's it? Yes, exactly. It's the rename refactoring. So most of the times people rename methods, rename classes. And I don't quite know why. That's when you use the IDE. For more complex refactorings, people often just do it by hand. Anyway, that's up to you. The more automated process you can use, the better. So here's a final quiz. The code smells. All signs for refactoring are given. When should you not start a refactoring? So we know when to start a refactoring because there's this code smell and it's so bad and it's like at least 3 times of duplicate code, etc., etc. When should you not start a refactoring? TA, please stop. All right, we are back. So when should you not start a refactoring? What are good reasons for not starting a refactoring? Well, maybe that code will never be touched. Not a particularly good one because you can rarely predict, but maybe you'll have to start or should start the refactoring only if you actually have to touch the code, because otherwise the code, you will not be able to work with the code. So what might other be reasons for not starting a refactoring? I'm not sure. Maybe you don't have the ability. Maybe you don't have good enough tests in place yet to tell you that you are just screwing up the code, you're actually not improving anything. Maybe if you were to embark on a refactoring without good tests, you would make things worse. I don't know. There might be many reasons and they could be project specific. That's it for right now. Thank you very much for your attention and see you next time.